This is TechSNAP, episode 422, for February 3rd, 2020. Hello and welcome to TechSNAP, Jupiter Broadcasting Systems, Network, and Administration podcast. My name is Wes, and I'm joined by Jim.
What's up, everybody?
Well, Jim, it's a good thing we weren't conducting this recording over Microsoft's Teams because as we record today, they've just recovered from a rather embarrassing outage.
Whoops, forgot to renew the SSL certificate, Wes.
Oh no, that can't be it.
That absolutely can be it. I wonder if anybody's told Microsoft about Let's Encrypt.
Yeah, it's 2020 now, and you sort of expect Microsoft to have this figured out. What makes it a little bit worse is this isn't the first time something like this has happened, is it, Jim?
No, it's not. When I saw the story about Teams and the certificate not renewing, the first thing I thought was, much like the sperm whale and the flower pot falling from orbit in Douglas Adams stories. Oh no, not again. In 1999, Microsoft forgot to renew the domain for Hotmail. And actually, I don't think it was the Hotmail domain itself, but one of their domains did not renew, and it broke Hotmail along with several other services, remained down for several hours. And in that case, in 1999, what eventually happened is some random Linux consultant who saw the story on Slashdot and just wanted to check his freaking Hotmail. He went on Network Solutions and renewed the domain himself.
Well, that's pragmatic.
Yeah, and the story kind of goes on from there. So he pays $35 to renew the domain name. Microsoft sends him a $500 check by way of saying thank you, and then he eBays the check for $7,100 and donated the proceeds to charity.
Well, Microsoft's lucky that someone with such a generous and good heart intervened, but these kinds of situations, they have serious impacts.
Yeah, they really do. And to be fair, we don't really know what happened at Microsoft with this one. It's really easy to make the snarky, like, hey, has anybody told them about Let's Encrypt? Because Let's Encrypt makes just automating these kind of things so much easier, on a small scale. And for somebody as big as Microsoft, it seems more likely they probably did have an automated process and the automated process failed and nobody caught it. But that, again, just kind of points to one of the strengths of Let's Encrypt. Microsoft's SSL cert expired every year. So you have this once annual action that is just absolutely critical that has to happen and has to go right or the whole site's broken, and it broke. One of the things that I really like about Let's Encrypt is in addition to, giving you a scripted, automated, hands-off way to, constantly renew your SSL cert when it needs it, they're shorter service certificates as well. So it has to renew every 90 days. It typically renews every 30. And because it happens more frequently, it puts more of an onus on you to say, hey, we should monitor this and make sure that it's all going right.
Right. If you have to do it all the time, you're going to get good at it and develop procedures around it.
When something happens just once a year, it's kind of easy to just be like, oh, well, it's cool, and we automated it. It'll be fine. And it is fine for a few years until it isn't. And if you weren't, doing automated monitoring on that, you don't catch it. And next thing you know, you're on the news.
And this would be sort of one thing if it was a random Microsoft client, but we've seen Microsoft pouring a lot of work and money into Teams to try to compete with Slack. So that kind of makes it extra embarrassing.
Yeah, definitely a little bit of a black eye there.
Jim, you're no stranger to managing certificates. Do you have any tricks up your sleeve to make sure an embarrassing incident doesn't happen to you or one of your clients?
Yeah, absolutely. I use Nagios for monitoring everything. The great thing about Nagios is you can do everything with it. The bad thing about Nagios is most people don't realize the cleanest way to do everything with it. And the silly way to do it is just go to individual host config and, create a service called HTTPS cert with check command, check HTTPS cert. And it just kind of does the thing. It lets you know, once your certificate is within 30 days of expiration, you get a warn and then a crit in Nagios. But the nicer way to do it is to create a host group. On my own configs, I've got a host group named web servers, and one of many checks that are run against all my web servers is HTTPS certificate checks. So if you place a server in the web server group, then it automatically gets all of its certificates checked. And if they ever do get within 30 days of expiration, which if you're using Let's Encrypt, they should not ever do that.
Right.
Then you'll get a warning.
Hey, that sounds pretty nice. And then you just got to make sure that you're monitoring Nagios and you've got your alerts notifying you.
Which the correct answer there is you need to if you have an Android phone, which you should, there's a free app called ANAG that works great for that. On iPhone, there are apps for that. I had to find one and install it for a client who wanted to monitor their own things. I can't remember the name of it. I want to say it cost like $15. But either way, having an app on your phone that actually pulls from the Nagios server is the correct way to do it. Because the app will not only alarm in your pocket if there's a problem with the service, it will also alarm in your pocket if it can't reach the Nagios server. And, as anybody who's done this for a while knows, the problem with email reporting is what happens when the email doesn't get to you. Well, nothing. You didn't get an email. No news is good news, right? Meanwhile, stuff's broke.
Yeah, that's exactly right. Someone has to watch the watchers. That's enough about Microsoft's failures. Let's talk about something they're getting right. Jim, you're all fired up about Edgium.
Edgium is a cute nickname for the new Microsoft Edge. To explain that, we got to talk about the old Microsoft Edge, which was Microsoft's replacement for Internet Explorer. They rolled it out to Windows 10 and Xbox One in 2015, and it's a ground-up proprietary design. At least in theory, didn't really share any code with Internet Explorer, and certainly not with anything else. And it wasn't really a bad browser. I never really found anything in particular wrong with it. But the problem is that by the time Microsoft dropped Edge, everybody who cared about a browser had already moved on to Chrome or Firefox. And that left people that were just trying to use the thing on the computer for whatever they were doing. And although Edge was okay, it didn't run Internet Explorer apps any better than Chrome or Firefox would have. So you're left with a thing that has the branding of the big blue E that only really appeals to people who like, the ancient crusty software that works the ancient crusty things, but it doesn't actually work with the ancient crusty things. Now, Edgium is a completely new ground-up rewrite of Microsoft Edge, and now instead of being based on Microsoft's proprietary Edge HTML and Chakra engines, Edge is built on top of Chromium, just like Google Chrome is.
That is a pretty big change. I mean, we've talked a lot about Microsoft and open source, but this seems to be a pretty clear move on their part. They're willing to embrace these useful open source projects to help build some of their own applications.
Yeah, this is really huge, in my opinion. We've heard a lot about the new open Microsoft and how, Microsoft loves Linux and Microsoft loves open source. And the messaging has been a little inconsistent, from the stance of a giant FOSS hippie like myself. You see tons of it at a Linux conference, but like if you go to Microsoft Ignite, you don't see Microsoft loves Linux stickers getting handed out in there.
Yeah, Microsoft is a giant corporation with a lot of competing interests, so it makes sense you'd see some Linux love at a Linux conference, but at Ignite, they have other priorities. But that doesn't mean they don't care about open source.
But, Microsoft has been making a lot of, open source contributions. They have thrown some of their own projects over the wall. But I can't think of anything else quite like Edge where they've taken an existing, really major open source project and both rolled it into Windows and, left the majority of it open and in fact contributed a ton to the underlying open source project that they lifted it from. I mean, we're looking now at Google and Microsoft engineers openly and publicly collaborating on a browser in Chromium. It's still a Google owned project, but the engineers are talking nice. Patches are being accepted. Large feature sets are getting merged into Chromium that Microsoft is contributing, and they're going to show up not only in Edge, but also in Chrome eventually. That's pretty cool.
It really is. I think it speaks to some of the core values of open source software, that we don't all have to reinvent the wheel. Multiple competing interests, people, companies, we can all have a shared base of software where it makes sense. And then, if you want, build on top of that, build something open source, or maybe build something proprietary that doesn't negate the benefits of working together. And while that's pretty great, there have been some concerns about the newfound browser monoculture, though. I mean, besides Firefox, Jim, pretty much everything is using Chromium or Blink or WebKit. Is this something you're concerned about?
It's of concern to a lot of people. It's really not of concern to me. Yes, we absolutely lost some code diversity when Edge HTML went away and got replaced with Chromium, but I don't feel that that's really significant. I think the significant thing to look at here is the world lost a proprietary code base that was being used to render, at least in theory, according to a published standard, and it got replaced with two really large companies that are, again, openly, publicly collaborating with a code base that anybody can use that actually implements that standard. Even if we said, and I'm not advocating for this, but even if we said, oh, well, what about a future when Firefox goes away also, and all we have is Chromium and Chromium-based browsers, I don't think that would be the end of the world by any means, because again, everything's out in the open. Google might host and control the Chromium repository, but when you've got engineers from these two competing companies that are both collaborating and doing so publicly, it's not just Google and Microsoft who can see what they're doing and who can use what they're doing. Everybody on the internet can. If you want to build your own Chromium browser, nothing's stopping you. If you want to add features, nothing's stopping you. If you'd like to see those features get, upstreamed back into Chromium main and then, out to Edge into Google, the only thing stopping you is doing good enough of a job at it that everybody agrees they want it in their own builds. That's exactly the kind of thing that we're looking for from open standards to begin with. So now, in addition to open standards from the W3C, we've got open implementations driving the web.
Well, that's enough about Microsoft for today, because we've got some great news over in the Linux world. The next kernel, kernel 5.6, is just chock full of goodies, not the least of which is WireGuard. Yes, that's right, WireGuard has been officially pulled into the 5.6 tree. I think that means our long wait is over, Jim.
Well, it's not over yet, but it's certainly getting pretty close. We should see 5.6 kernels dropping sometime around like April or May of this year. Now, that's not going to be soon enough to get WireGuard in the 5.6 kernel into most people's mainstream distributions. However, if you happen to be running Ubuntu, WireGuard support has also landed in the kernels for the 2004 LTS coming up in April.
And while that might sound like a small thing, actually kind of means a lot for the short-term adoption of WireGuard, I think. Ubuntu 24 is going to be the first real stable Linux kernel, a major LTS from a distribution. It's going to be supported for a long time. I'm not going to see things like Debian 11 or Red Hat 9 for at least a year or some years in the case of Red Hat. But 2004, there's going to be a lot of products and server installations based around it. Hopefully, this provides further incentive for widespread WireGuard adoption. I'd like to never use OpenVPN again if I could help it.
I think at this point, the only really valid use of OpenVPN is if you're behind a firewall that's obnoxious, but not quite as obnoxious as possible, and so you can get out on TCP 443.
Well, besides WireGuard, which we've all been eagerly awaiting, its author, Jason Dunnenfeld, landed some other major improvements this time around.
Yeah, Jason also optimized the Poly 1305 crypto cipher, which WireGuard consumes Poly 1305, but Poly 1305 isn't in the WireGuard module itself right now. It's an in-kernel cipher, and the optimizations that Jason made have been accepted into main, just like WireGuard itself were. And there are a lot of projects that use that. For example, Polybius 1305 ChaCha 20 is the cipher that I used for almost all of my SSH tunnels for ZFS replication up until a couple of years ago.
Yeah, that is a great point. It's not just WireGuard that can make use of these improvements. Anyone consuming the kernel's algorithm here, well, they're going to get a speed up.
Yeah, and to be clear, this is not just theoretical. There are a lot of projects that are using Poly 1305 right now that will see immediate improvements out of this. And it's not an insignificant optimization either. In his commit, Jason has a table demonstrating CPU cycle optimizations and comparing, the prior implementation to the new one that he has submitted. And you'll frequently see, half the CPU cycles used do the same amount of work.
That is pretty great. And thankfully for us, there's even more in kernel 5.6, including initial prerequisites for Multipath TCP. Now, you might recall that the Linux kernel has had an out-of-tree implementation of Multipath TCP for almost 10 years now, but recently we've seen a resurgence in interest in getting upstream support finally happening, and in kernel 5.6, the first steps have been taken. Jim, why do we want Multipath TCP?
Well, we care in part because Multipath TCP allows us to aggregate multiple links and get more aggregate throughput than we otherwise would have. Kind of like bridging ports on a switch. It also allows you, at least in theory, I hesitate to make bold claims about tech that I haven't really practiced with yet, but in theory, you should be able to do things like enable multipath TCP when you have multiple interfaces on your phone. Maybe you've got it connected to both Wi-Fi, and to your telco, and you're making a call and you walk out of the house and move from Wi-Fi to the telephone company only and never drop a packet.
The fundamental idea of multipath TCP, described by RFC 6824, is that you allow a single network connection to exchange data over multiple physical paths. And, these days, many of us have devices with multiple paths all the time. Apple added multipath support way back in 2013, and some Android vendors have patched their own kernels to add support. But with some recent renewed interest in upstreaming, including a great talk at last year's Linux Plumbers Conf all about upstreaming, where you can watch some fun back and forth between the project and kernel maintainers about the right way to get things done. And there are some tricks here to get right. Multipath TCP looks a lot like regular TCP. That's in part because in the real world, with protocol ossification and old middle boxes out there, it has to. But kernel maintainers are insistent that it needs to work. It needs to support IPv6, and it needs to be reliable before it can get merged.
Working code seems like a pretty good minimum bar.
Yeah, I agree. Jim, you mentioned the mobile use case when you're leaving home and want a graceful network transition, and that's exactly what Apple's support allowed them to do.
That would absolutely be the dream, because I got to tell you, I have administered a lot of sites with various different solutions for LTE failover or dual WAN failover, and they're not that reliable.
I'd love to see similar support in all Linux-powered phones, especially those that might be more open. It might also help support get enabled in your residential gateway to easily add something like LTE failover, and I would love that. Something else that caught my eye is Multipath TCP is already a part of 5G standards, which makes support in mainline Linux all the more important. I'll note again that it's not full support landing in 5.6, just some necessary prerequisites, but nevertheless, it's a foot in the door, and I'm already looking forward to the next release. Unfortunately, it won't be protecting us from the latest Intel flaw, though. Yeah, that's right, there's another Intel hardware vulnerability.
As usual, this one has a catchy name. It's called the CacheOut attack.
Leaking data on Intel CPUs via cache evictions. It's a new speculative execution attack that's capable of leaking data from Intel CPUs across many security boundaries, and that's where it's maybe more of a big deal. Leaking data from the kernel, co-resident virtual machines, and even SGX enclaves.
What's different with CacheOut is the attacker can actually select the data that they're looking for and cause that data to be evicted and become made available to them.
Yeah, that's a big difference. Although we should note, it still doesn't necessarily make the attack easy.
Well, Wes, whether CacheOut is easy to exploit kind of depends on your definition of easy. It's not easy in the sense that you can't trigger it just from running some JavaScript in a browser. So users don't have to worry about literally just loading a website and getting owned via CacheOut. But if the attacker can run code under a normal user context on the system, they can leverage it to extract info from the kernel that makes other attacks possible. So modern operating systems Linux, Windows, BSD, you name it, they use something called address space layout randomization. And what that does is it loads different pieces of code into a different random place of memory every time the operating system loads or the application loads. It also implements something called stack canaries that can detect whether or not the stack has been modified. And that makes it much more difficult to pull off the old buffer overflow attack. If you're not familiar, a buffer overflow basically just means you gain the ability to write to a piece of memory that some other program will later execute. And when you do that, that allows the attacker to just have that code executed under the context of the application that jumps to that location in memory. Now, with address space layout randomization, you don't know where to try to smash the stack, so you may be able to make the computer crash, but you can't just arbitrarily do whatever you want to with it. Similarly, if the system detects via stack canary that a piece of memory has been modified that should not have been, it will crash the application rather than allow it to execute that code. But with CacheOut, you can gain the information that you otherwise would have been missing about where those pieces of memory are that you might want to overwrite, with your crazy custom attack code, and where those canaries are so that you can modify them also so that it doesn't look like anything's been touched. So now you can pull off an old school buffer overflow attack like it's 1999. So in addition to enabling old school buffer overflow attacks that should have been mitigated by ASLR and stack canaries, you can also leak information from pretty much any other process that's running on the same thread or across threads on the same CPU core. You can get decrypted output from encrypted communications. You can leak actual keys from processes that are doing AES decryption. The other big thing here is that the mitigation work that Intel has already done to nerf Meltdown and Spectre and make them not quite as big of a deal as they used to be doesn't have any impact on CacheOut.
The flaws continue.
And we should probably mention that this is an Intel-specific vulnerability. AMD processors don't have anything like the TSX instructions, so they are not vulnerable to CacheOut. ARM and IBM processors do have features similar to TSX, but the authors of CacheOut, they don't really know whether any of those processors are affected. They just haven't tested them.
As with many of these speculative execution vulnerabilities, it's something of a big deal for cloud providers who use virtualization to ensure security between the various virtual machines running on their platform. Thankfully, there has been some responsible disclosure in the case of CacheOut, and many cloud providers have already provided some mitigations against this. That said, I think the era of flaws in modern processors is bound to continue. And when they appear, you can be sure we'll talk about them here on TechSNAP. That's it for today's episode, but of course there's always more over at TechSNAP.systems. You can find links to everything we've talked about today at TechSNAP.systems/422, but also there are easy ways to subscribe and get in touch. If you want more Jupiter Broadcasting, well, head on over to jupiterbroadcasting.com and check out Linux Headlines, which is all the Linux and open source news you need in 3 minutes or less. If you want more Jim, you'll find him writing over at ours, and he's also on Twitter. Jim, you're
At JRSSNet.
I'm there too. I'm at Wes Payne, and the whole network is at Jupiter Signal. Thank you so much for joining us.
See you in a couple of weeks, everybody.